marble is metamorphosed limestone.
If you look, you can even see quite big shells here.
We're going to go on a field trip in Milton Keynes Shopping Centre.
It's not the first place you'd think of for geological wonders, but it is amazing what you can find in a shopping mall.
Banks use rocks to convey a sense of reliability and permanence.
And local authorities use attractive building stones to put on their public buildings and in public spaces.
Sometimes retailers will use rocks to convey subtle messages about the quality of their wares. Let's go see what we can find.
Come and have a look at this. So this is a beautiful igneous rock. So what igneous means is that the rock was actually molten. This rock was once a liquid and it cooled and crystallised and formed like this. You can see here there are some bigger crystals. These orangey ones, browny orangey ones, sort of stand out as being better formed than the ones in between. And what often happens in an igneous rock is that there's always a first crystal to crystallise out. And it's often something called a feldspar. Now, I'm guessing that this is what these are. It can be quite hard to tell when you look at something in hand specimen, which is what we call looking at a big rock. But I'd say they probably are. So these crystals will form first, and that's why they have quite a good shape. You know, they have quite a sort of round, maybe slightly oblong-y shape. This one's even got a slightly pointed end. And the other ones, they actually formed later. So they tend to fill in the gaps in between. So here we've got probably, but I'm not 100% sure, this could well be quartz, this grey one, and then the black one could well be mica, but it might be another dark mineral. And these tend to form later, at slightly cooler temperatures, and fill in the gaps between these bigger ones.
So they've squeezed into the space left behind.
Yeah, exactly. And so when you've got the big ones, you'll have, I suppose you could call it like a crystal mush, and it'll have solid bits and liquid bits, and then gradually the amount of liquid gets less and less and less, filling in the little spaces until at last you've got maybe these tiny weeny bits. And that's something about igneous rocks. That's why they have quite an interlocking texture, because they all grow together, but they fill in the gaps one by one until there's no space at all.
So this looks pretty promising. So what have we got? We've got lots of large crystals. If we look at them, they look like they're all touching each other. They look like they're interlocking. There doesn't appear to be any kind of cement in between them, so that tells us this is igneous or metamorphic. If we stand back, I can't see any kind of lineations. There doesn't seem to be any order or any structure in how the crystals are arranged. So that tells us that this is almost certainly an igneous rock. And if we look a bit closer, we can see that the difference between this igneous rock and the one Anne was showing earlier is the colour, basically. This is much lighter in colour, and that's just because some of these minerals are much whiter than was in the igneous rock that Anne was showing us earlier.
So does that reflect different materials or different conditions?
Different materials probably, so slightly different chemical makeup of the magma from which this crystallised. And I mean, another nice thing about this one is you've got some really big crystals in this one. You can probably see some crystal faces on this. And that might suggest that these were the first things to start crystallising, and then the rest of the material has kind of grown around it.
If we look at this one carefully, can you see it's made up of lots of different pieces, little bits, fragments, I suppose. This is a sedimentary rock. So a sedimentary rock is made up of bits of other rocks, and that can be bits of, say, quartz grains to make a sandstone. This is actually made up of shells, and possibly some bits of limey sand, but there's huge numbers of shells in here, forming bands as they go. Some are coarser grained, big bits, and some are much finer bits. But this would have been laid down probably in a sea. So some of the shells that we have here, you'd even find on the beach if you went today. So you've got this beautiful big shell here, which is one that hasn't actually been broken up, which is quite amazing. And then we've got the layers here of the sort of coarser grain and finer grain, and sedimentary rock is just where you've got layers of rock building up over time, one on top of another.
So you can almost see the passage of time.
Yeah, you really can. It's amazing.
So what have we got over here?
Well, that looks like something, doesn't it?
Yeah, definitely. So if we take a look at this, what do we see? So it's obviously quite fine grain. We can't really see the individual grains for most of it, but there are these little bits and pieces all over the place. There's things like this, that there, don't know what that is. So let's have a look around on this. I mean, there's something here that looks like it might be part of a shell or something. But then down here, I mean, this is really obvious. So this looks like an ammonoid of some sort. Yeah. So really big fossils, but this would have been bobbing around in an ocean 139 to 400 million years ago. So even if you've got this kind of really fine-grained stuff where you can't see the relationship between the clasts, if you've got something as obvious as this, then you can be really confident that that's a sediment.
And this one is actually made of something similar to what you find in your kettle. So you have hot water that's at pressure underground, and it's going through limestone that's already there. When it reaches the surface, you get a drop in pressure and a drop in temperature, and the calcium carbonate that's in the water precipitates out. It comes out of the water and forms a layer of this calcium carbonate.
Yeah, immediately you can look at it and it looks like it's grains which are interlocking. They're all touching each other. We can see a few different minerals in here too. You can see these red things that really stand out, maybe some white stuff, some greyer material, and then this black speckledy stuff. So that tells us it's probably igneous or metamorphic straight off, just because of the way the crystals are interlocking together. If we look at it from a distance, you can start to see that there's some kind of organisation in the way that the grains are ordered. So there's these kind of bands maybe. And over here too, you can see there's these darker areas and then these lighter areas, and they seem to be organised in some kind of way. And actually looking behind you, there's some really great banding over here. So you've got these bands of darker minerals, and then this lighter stuff, and then this kind of darker stuff again. And the other thing that immediately catches your eye about this rock is these red minerals. And I think these are probably garnets. A lot of the minerals in here we'd have to have a look a lot more detailed and maybe under a microscope to see what they really were. But these, if they are garnets, that's really diagnostic of a metamorphic rock.
Now it's your turn. We want you to go out and find some interesting rocks of your own. It might be in the floor of your bank, it could be in your local shopping centre, or it might just be in your garden wall. You shouldn't have to go far to find something interesting.
Remember to find something with quite big grains so you can see how they fit together.
We want you to have a go at identifying whether your rock is igneous, metamorphic, or sedimentary.
Now your sedimentary rocks will be little pieces of other rocks stuck together with some kind of cement. Your igneous and metamorphic rocks will have the grains actually interlocking, and your metamorphic rocks might have some kind of alignment, but you'll often have to step back to see it. Good luck and happy hunting!